Hey guys, how's it going? Welcome to your lesson on creating equations and inequalities in one variable. Heads up, this is a longer lesson, much longer than the first two. This lesson and the next one are a little bit longer. The one after that, which is the final lesson of the unit, is back to a shorter lesson. And that's because we're combining creating equations and inequalities into one lesson because they're so very similar. So we're going to go over the annotation part first, and I'm going to do a little bit of highlighting. I think my highlighting skills are getting pretty good. All right, so creating equations from context is important since most real-world scenarios don't involve the equations being given. All right, as I've told you before, an equation is a math sentence that uses an equal sign to show that two quantities are equal. So whatever's on the left side is equal to whatever's on the right. A quantity is something that can be compared by assigning a numerical value. In this lesson, context will be given and equations are going to be created from them and then used to solve problems. Since these problems are all in context, units are essential because without them, the numbers have no meaning. And you guys have been using units forever. We talk about grams or milligrams or whatever. Without a unit, the number doesn't mean anything. And so when we apply math to real world situations, it's the unit that makes it real world. So a linear equation is an equation that can be written in the form ax plus b equals c. Okay, so we have one term here, another term here, and another term here. Okay, this term ax, there's two. There's a coefficient and a variable, and b is just a coefficient, and c is just a number, a constant. I mean, not a coefficient. So a is a coefficient, b is a variable. Okay, hold on. Start over. A is a coefficient. X is the variable of that coefficient a, and we're going to do numbers in a minute. Actually, we're going to do numbers now. 4x plus 2 equals 16. So the 4 is our coefficient. The x is our variable. The 2 is a constant, and 16 is a constant. 16 will change, though, as x changes. So A, B, and C are rational numbers. Often the most difficult task in turning a context into an equation is determining what the variable is and how to represent it. Variables are letters, and they're used to represent a value or unknown quantity that can change or vary. And once the equation's determined, solving for the variable is pretty straightforward. We're going to use either addition, subtraction, multiplication, or division. Those are the four main operations that we'll use to solve equations and inequalities. The solution will be the value that makes the equation true. So when we have one thing that equals the other thing, the solution is the thing that makes it equal the same thing on both sides. In some cases, the solution will need to be converted into different units. So multiplying by a unit rate or a ratio can do this. We'll talk about that if we get this part. We'll talk about that later, so don't let it freak you out. A unit rate, I know you guys have had unit rates since 7th grade, and actually probably much before 7th grade, but really heavily in 7th grade. A unit rate is a rate per one given unit, and a rate is a ratio that compares different kinds of units. Use units when you're doing math that makes sense. So when you're reporting time, you're going to use, if it's something that's less than an hour, you would report your answer or your explanation in minutes. You wouldn't say 3/4 of an hour, right? You would convert that into minutes. And then you think about rounding and precision. The more numbers you list to the right of a decimal place, the more precise the number is. And when you're using measurement and calculations, only report to the nearest decimal place of the least accurate measurement. We'll go more into that into our shelf work, and then see guided practice example 5. Don't worry about that for right now. So creating equations from context. These are some steps that will really help you. Read the problem first. Reread the scenario and make a list or a table of what you know. So Again, the first time you read it, you're not doing anything but reading it. You have to orient yourself with what it's asking before you start to try doing anything. And in all the years I've taught math, I see students time and time again just wanting to jump right into it. Don't do that because you're going to end up creating a lot more problems for yourself. Be patient and slow down. So once you read it, you're going to read it again and make a list or a table of what you know. And then you're going to read it again and you're going to identify the unknown quantity or variable. So 1, 2, 3 times you're reading it. Then you can create expressions and inequalities from the known quantities and variables. Once you create your expression, you can start to solve. And then once you solve, you create, you solve, and then you interpret. What does it mean? What does this number that I just solved for mean? Common errors and misconceptions, attempting to solve it without reading it. What did I just say? Incorrectly setting it up. You will incorrectly set it up if you did not read it carefully. You will also misidentify the variable, forget to convert to the correct units, set it up inversely, which means the opposite way that you should have, report too many decimals. All of that happens when you don't stop and take your time to read it initially. Okay, so we are, for the guided examples, we are skipping example number 1 and number 2, and we will do those in the lesson. So we are going right to number 3. Suppose 2 brothers who live 55 miles apart decide to have lunch together. To prevent either brother from driving the entire distance, they agree to leave their homes at the same time, drive toward each other, and meet somewhere along the route. The older brother drives cautiously at an average speed of 60 miles per hour. The younger brother drives faster at an average speed of 70 miles per hour. How long will it take the brothers to meet each other? So we just read it once. We did not write anything down, okay? So now we're going to read it again. Suppose the 2 brothers who live 55 miles apart decide to have lunch together. To prevent each brother from driving the entire distance, they agree to leave their homes at the same time. They drive toward each other and meet somewhere along the route. The older brother drives cautiously at an average speed of 60 miles per hour, and the younger drives faster at 70 miles per hour. How long will it take the brothers to meet each other? We're going to reread it again and make a list of known quantities. So problems involving how fast or how far require a distance equation, where d equals the rate times the time, okay? Distance equals rate times time. So the older brother, we can make a table or we can just jot it out, whatever you're comfortable with. The older brother is driving 60 miles per hour and he's going for 55 miles. They're both going 55 miles. The only thing that's different is their speed. Okay? We're going to read it again and look for the unknown or for the variable. The scenario asks for how long. So how long is a time? That's t. So we're going to create an expression, an inequality, in this case, expression from the known quantities. So we have distance equals rate times time, or speed times time. And we're going to start plugging some things in. So we've got together the brothers travel a distance of 55 miles, okay? The D is 55. That's where this comes from. And then we have the older brother's rate times the time and the younger brother's rate times the time. So now we can set up an equation. We have older brother is 60 miles per hour times the time, and the younger 70 miles per hour times the time. Together, they drove 55 miles. So that's basically what we just did. We add the distance equations, and we set it equal to 55 miles because that's how far they both drove. Now we are going to combine. We have got some like terms. We have 60 plus 70, which is 130. T equals 55. Now, after we combine like terms. This is new when we solve an equation. And you guys did this in 7th and 8th grade, but it's been a long summer and you may not remember. So whenever you have right here, you have a number attached to a variable, you, in order to get that variable by itself, have to do the opposite of whatever it is. And it's either, when I say the opposite of whatever it is, it's going to be multiplication, division, addition, or subtraction. When you have a number squished up next to a letter without anything else, it's always multiplication. And so in order to undo multiplication, the opposite of multiplication is division. So that's where you divide by 130. That sign, that fraction bar is the same as divide. So 130 divided by 130. And what you do to one side in an equation, you have to do to the other. So that's why you see 130 on both sides. So 55 divided by 130 is 0.42 hours. So it will take the brothers 0.42 hours to meet each other. Now, note the answer was rounded to the nearest hundredth of an hour because any rounding would not make sense. Most people wouldn't be able to or need to process that much precision, okay? So when you're talking about meeting someone, you're not going to tell them, I'll meet you in 0.0424789 minutes. You're going to round and say, I'll meet you in about 20 minutes. And because we're saying 0.42 hours, we need to figure this out in minutes, okay? So we have 60 minutes as an hour, and we've got 60 minutes in 1 hour. So we're going to multiply 60 minutes by 0.42 hours, and that's going to give us 25.2 minutes. So the brothers are going to meet each other in about 25 or 26 minutes, if we're being realistic. There you go. The fractions formatted kind of weird. Okay, we're going to reread it and make a list of the known quantities. So for this example, we have our length is 9 feet, 11 and a quarter inches. So instead of dealing with fractions, I'm going to deal with decimals because they're easier to work with when you're doing anything with a calculator or adding and subtracting and lining numbers up. So our length is 9 feet, 11.25 inches. So 1/4 is the same as 0.25. And the width is 1/2 inch less than 3 feet. 1/2 inch less than 3 feet. So let's make this an easy thing to digest. 3 feet is 36 inches. And if it's 1/2 inch less than 3 feet, we're going to take 36 inches minus 1/2, and we're going to get 35.5 inches. So now we're working in 9 feet, 11.5 inches here, and 35.5 inches there. We're going to read it again and look for the unknown or the variable. So the scenario asks for the surface area of the car's top. We're going to work with the accuracy component after calculating the surface area. Okay, so surface area, our soapbox derby car is tapered, so we're going to have to assume a little bit, meaning that it's wider at one end than the other. And to be sure Ernesto has enough paint, he assumes, you don't have to assume, but he does, that the car is rectangular with the width being measured at the widest location. So we have area equals length times width. And we have converted the length to inches. So we've already done the width. So we're going to take 9 feet, 9 times 12, because 12 inches in a foot, plus 11.25 is going to give us 119.25. So what we're doing is we're making our numbers have the same units. Otherwise, we can't combine them. They're not like terms. Okay, so now we're going to substitute the length and the width into the area formula. So we've got area equals length times width. And so we do 119.25 times 35.5, and we get 4,233.375. we are going to, this is going to give us a numerical result for the surface area, but the problem asks for the most accurate surface area based on his initial measurements. So the surface area at the top of Ernesto's car is 4,233.38. You're going to round. And so we're going to convert if necessary. So when buying paint, the hardware store is going to ask how many square feet need to be covered. Ernesto has his answer in terms of square inches. So now we have to convert from square inches to square feet. All right, so again, they're in a square foot. There are 144 square inches, and the reason for that is because 12 inches in a foot times a square. If you drew it out, it would be 12 times 12 is 144. So in this case, when you're setting it up, you can also put this over 1. These are ratios. So you've got your fraction. You notice that the inches squared, those are going to be your double-edged swords, and you are going to line them up diagonally. So you've got inches squared up at the top, you're going to have inches squared at the bottom, and therefore these are going to cancel out, leaving you with feet squared. But you're also going to need to divide, so you're dividing 4,233.38 by 144. Again, rounding. So we did some rounding to make it in feet squared, and we are done. All right, moving on to the second part of this lesson. So the second part of this lesson is inequalities, and inequalities are similar to equations in that they're mathematical sentences, but they're different in that they are not equal all the time. An inequality has infinite, meaning a whole lot of solutions instead of only having one like an equation. Setting up inequalities will be the same exact process as you just did with equations. Solving them will be similar with 2 exceptions. And you learned how to do these in middle school, so this will be review. The prefix in means not. In means not. And inequalities are sentences stating that 2 things are not equal. Not equal. So 12 is greater than 2, and 1 is less than 7. So this is less than, that is greater than. Remember, these symbols are used with inequalities, and there's the next slide has a table with some symbols and examples with their solution sets. Okay, I'm not going to read this to you, but this is here for you in your packet for you to reference when you are solving and creating equations or rather inequalities. Okay, and that is on page U1-59 in your packet. If we have 2 is less than 4, 2 is less than 4. It is true, 2 is less. If you multiply both sides by -2, then the inequality becomes -4 is less than -8, which means it flips. Is -4 really less than -8? To make the statement true, you must reverse the inequality symbol, because when you're dealing with negatives, -4 is not less than -8. -4 is closer to 0, which means it's greater than -8. You're always going to deal with inequalities in terms of how far is it from 0. This is, again, in your annotation section, creating inequalities from context. This is on page U1-60. We're going to do the same thing we did, only we're going to keep our eye out for multiplying and dividing by negatives. Common errors and misconceptions are not translating the words into the correct symbols. So when you have phrases such as no fewer than, no more than, at least as many, that means it's going to be either less than, greater than, less than or equal to, or greater than or equal to. So you really have to know what words go with which of these symbols. Let me circle them because that made it a little confusing. Which of these symbols? Also, forgetting to switch the inequality symbol by multiplying or dividing. That's a biggie, biggie, biggie. I've seen so many students forget to do that. and then not interpreting the solution in terms of the context of the problem. All right. Woohoo! Here we go. We're almost there. So again, remember, feel free to take a break. Feel free to get some water and come back. We're going to do example 1 and 2, and example 3 is going to be done in our lesson. So we've just got 2 examples and then we're done. Hang in there. All right, Juan has no more than 50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what's the maximum price of jeans Juan can afford? I know y'all have been in this situation before where you're at the mall or wherever and you're like, what can I buy with this amount of money? And sometimes you get up to the register and you don't have enough. So knowing this stuff is super helpful. Even if you don't write it out in equation form, it's really helpful for your brain to think through how to do it. Okay, we're going to read that bad boy again. You can read it on your own. We're going to reread the scenario and make a list or table of the known quantities. So we know right here, Juan has no more than 50 to spend. That's in the first sentence. He wants to buy a pair of jeans and some juice. There's nothing in that sentence that gives us any information except for we know he wants to buy 2 things. If the sales tax on the jeans is 4%, there's that. And the juice with tax costs $2. So the juice costs $2. That's all we know, those 3 things. Now we're going to read it again, identifying the unknown quantity or the variable. So we read it again. Juan has no more than 50 to spend at the mall. There's nothing unknown in that sentence. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs 2, what's the maximum price of jeans Juan can afford? So the unknown quantity is the cost of the jeans. So we're going to now create expression and inequality from the known things that we were given, the quantities and variables. So we've got the price of the jeans, okay? We have X, meaning we don't know how much the jeans cost. That's X. And I'm going to actually write this out. Jeans. We have got the tax on the jeans. Tax on, I'm using my fingers, so this is kind of funny. Jeans plus the price of the juice is less than or equal to the amount of money Juan has. Okay? The price of the jeans plus the sales tax for the jeans plus the $2 juice that he's going to buy needs to be less than or equal to $50. He can spend 50, but he can't spend more than 50. All right, so we're going to solve the problem. First, we're going to add our like terms. We have X and we have 0.04X. Those are like terms. That's going to give us 1.04X plus 2 is less than or equal to 50. All right, so now we need to get X by itself. That is our goal. In order to get X by itself, I'm going to do a little bit of math off to the side. In order to get X by itself, we're always going to, you see this guy, the constant? Whenever there's a constant to one side of either your inequality or your equal sign, you're going to want to get rid of the constant first. So we are going to do this. I'm going to work down here. 1.04X plus 2 is less than or equal to 50. Getting rid of the constant first. So if it was a plus sign, we're going to do the opposite, which is minus, and we're going to subtract on both sides. So that means it's going to give us 1.04x is less than or equal to 48, which you see right here. Next, we have our coefficient and our variable right here. In order to get this bad boy by itself, we divide by whatever that number is. So we've got 1.04x divided by 1.04. These cancel out because they're the same. And then we have 48 divided by 1.04, which is going to give us X is less than or equal to 46.153846. We're going to round to 46.16. Interpret the solution. Juan should look for jeans that are priced at or below $46.16. All right. Last question, you guys, are math rock stars. We're going to do number 2. Alexis is saving to buy a laptop that costs $1,100. So far, she's saved $400. She makes $12 an hour babysitting, which, by the way, is totally common. So if you guys are looking for some work, you should consider babysitting. $12 an hour is what Mr. Andrew and I pay our babysitter. And our kids are pretty old, and so our babysitter has it pretty easy. So just saying, go get Red Cross certified and become a babysitter. You can make some good money. All right, so what's the least number of hours she needs to work in order to reach her goal? Reread it. I'm not going to read to you because you guys are rock star readers. Okay, we're going to make a list of the table, a list or a table of the known quantities. She has saved $400. She makes $12 an hour, and she needs at least $1,100. Okay, we're going to read it again. Identifying the unknown quantity or variable. You need to know the least number of hours Alexis must work to make enough money. So we are solving for hours in this case. So Alexis saved money, $400, plus her earned money, which is $12 per hour. Whenever you have the word per, here's a little note for you. Per means divide when you're going to undo it. So we've got 12H. So in order, when I say undo it, you're going to solve for H. In order to H by itself, you're going to end up dividing. Okay? So when you write per, initially, before you solve for it, it's going to be multiplication. So $12 per hour. In order to get the hour alone, you'll do the opposite of multiply, which is divide. And is greater than or equal to 1,100. We have to have a greater than or equal to because she needs at least that much money. I gotta start over. 400 plus 12H greater than or equal to 1,100. Okay, lonely 400 is moving over. My arm is not going to touch the mouse pad and change slides again like it just did. Those are going to cancel because 400 minus 400 is 0. This is coming down, so we've got 12H. This comes down. And 1,100 minus 400 is 700. Now, 0 goes away. Undo this multiplication, 12 times H, and divide by 12, divide by 12, these cancel. H is going to be this, 58.33333, repeating. So in this situation, it makes sense to round up because babysitters usually get paid by the hour or half hour. Therefore, Alexis needs to work at least 58.5 hours to make enough money to save for her laptop. 58.5 hours. When Don Andres and I go out to dinner and maybe we'll run some errands, go by Target, whatever, we usually are gone for about 5-6 hours. So if you think of it that way, if you're gone about 5 or 6 hours and you need 58.5 hours to make $1,100, that's only like 6 days of babysitting. So think about that as you guys start to, think about making your own money and supporting yourself. This has been so much fun. I cannot wait. Thank you for hanging in there. And you will not have many long lessons like this year, a handful here and there. So thank you. Can't wait to see you guys again.